So let's take a look at derivatives. So let's say here on the screen I have the graph of f of x, and I'm trying to find the derivative of the graph of f of x at these 3 points. So these ones highlighted in black. So the way we write this is, once again, we're trying to find the derivative of the function at a specific x value. So the way you write it is f prime, because remember prime signifies the derivative. So we're trying to find f prime, or the slope of the curve, at the specific x value of -1. So f prime of -1, or the derivative at the x value of -1. Now we're just going to estimate, but the way you estimate the derivative here is basically draw a tangent line to the point. So remember, the tangent line only touches that point and nothing else on the curve. And so the slope of this tangent line, since it's a horizontal tangent, is basically 0. Okay, because the slope is 0. So now let's move on to the next point here. This is at the x value of 0, right? So that's at the x value of 0. So we're basically trying to find the derivative, or f prime of 0. Now if we go ahead and estimate, we draw the tangent line, and the slope of that tangent line we could estimate to be around -1. So let's just say f prime of 0 is around -1. And then at this third point here, this is at the x value of 3, so we're trying to find f prime of 3. Now if I draw the tangent line to that point, it might look something like this. And so we could say that's around, the slope is around 2, 3, or 4. So let's just go ahead and say it's 3. So that's how you can estimate the derivative, by drawing tangent lines on the graph. Now, given a function f of x, the formula for the derivative of f of x, or in other words f prime of x, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And so this is known as the limit definition of the derivative. So for these next set of problems, let's go ahead and find the derivative, or f prime of x, using the limit definition. So number 1, we have f of x equals 3 minus 2x plus 4x squared. So once again, the formula for the limit definition of the derivative, f prime of x, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So now let's go ahead and evaluate this. So I'm going to rewrite the limit. So the limit is h approaches 0. Now notice we have f of x plus h. So all we have to do here is plug in x plus h, 4x, into the function. So f of x plus h is going to be 3 minus 2 times, once again we're going to plug in x plus h, 4x, everywhere in the function. So we have 2 times x plus h, and then plus 4 times, once again we're going to plug in x plus h, 4x. So x plus h squared. So now we have minus f of x, so just minus the function itself. So minus 3 minus 2x plus 4x squared, and then all over h. So now we can just go ahead and simplify. I'll just focus on the fraction itself. So we have 3 minus, I'll distribute the 2, so minus 2x minus 2h, and then plus 4 times. Now x plus h, the entire thing is squared, so I must FOIL. So x plus h squared is going to be x squared plus 2xh plus h squared. And then I can go ahead and distribute the negative inside the parentheses. So I have minus 3, and then plus 2x, and minus 4x squared, all over h. So now I'm just going to go ahead and simplify even further by distributing the 4 into the parentheses. So we have 3 minus 2x, or minus 2h, plus 4x squared, plus 4 times 2xh is 8xh, and then plus 4h squared. And we have minus 3 plus 2x, and then minus 4x squared, all over h. Now the good thing here is that many of these terms will cancel. So notice 3 and negative 3 will cancel. Negative 2x and positive 2x will cancel. Positive 4x squared, negative 4x squared will cancel. And so we're left with negative 2h plus 8 times x times h, and then plus 4h squared over h. So now realize on the numerator, I can go ahead and factor out h. So we have h times negative 2 plus 8x plus 4h all over h. Those will cancel. And so we're just left with negative 2 plus 8x plus 4h. So now that we have simplified this entire thing down to just this, now I can rewrite the limit. So we have the limit as h approaches 0 of negative 2 plus 8x plus 4h. And I can just use direct substitution and plug in 0 for h. So when I do that, when I plug in 0 for h, 0 times 4 is 0, that will cancel. And so we're just left with a negative 2 plus 8x, or just 8x minus 2. which once again is equal to the derivative, or f prime of x. So this will give you the slope of the curve, or the derivative, at any given value of x. So now for number 2, we have f of x equals the square root of x. So once again, f prime of x, or the derivative, we're going to use the limit definition. So we have the limit as h approaches 0 of f of x plus h. Now once again, for f of x plus h, all we're going to do is plug in x plus h, for x, into the function. So when we do that, we get the square root of x plus h minus f of x, so just minus the function itself, minus the square root of x all over h. Now if I use direct substitution, I plug in 0, I'll have to divide by 0 because it's in the denominator, so we cannot use direct substitution. However, in order to simplify this, I can go ahead and multiply by the conjugate. So I'll multiply by square root of x plus h. Instead of the minus, the conjugate is going to be plus the square root of x over that same value here, x plus h plus the square root of x. So now I can go ahead and FOIL the numerator and just multiply the denominator here. So then when I multiply, we'll get square root of x plus h times the square root of x plus h, which is just going to be x plus h, and then negative square root of x times positive square root of x, which is just going to be negative x, over, and I'm not going to distribute the h, I'm just going to leave it as it is, and so we have h times square root of x plus h minus, or plus the square root of x on the denominator. Now x and negative x will cancel, so we're left with h over h times square root of x plus h plus the square root of x. And realize that h's will also cancel, so we're left with 1 over the square root of x plus h plus the square root of x. So now that we have simplified this entire thing down to this, we can go ahead and rewrite the limit. So f prime of x is equal to the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. So now I can go ahead and use direct substitution. If I plug in 0 for h, we'll basically get 1 over the square root of x plus 0, which is square root of x, plus the square root of x. Square root of x plus square root of x is 2 times the square root of x. So the final answer for the derivative, f prime of x, is going to equal 1 over 2 times the square root of x.